Good morning. So here, so far we have discussed the Poisson process. Now I am coming to the birth and death process. We know that in Poisson distribution, lambda is a constant irrespective of the events occurred before. So here let xt is the Markov process at time t. Let us suppose that xt moves from n to n plus 1, then the process is called as the birth process, and if xt moves from state n to n minus 1, then process is called as the death process. So in general, exponential model which can go to state from n plus 1 or n minus 1, state n is called pure birth and death process. So here are the examples. Waiting time system in a queue. Suppose if there are n people in the system, then new arrivals entering into the system at an exponential rate lambda n, and people who are leaving the system, it is an exponential rate with mu n. Then lambda n, mu n are known as arrival and departure rates respectively. Lambda n, mu n follows exponential distribution with parameters mu and lambda respectively. The same example I am explaining, all given biological system. Here come to pure birth process. A birth and death process is said to be pure birth process if mu n is equal to 0 for all n. An example of pure birth process is Poisson process, which has a constant birth rate that lambda n is equal to lambda. So here I am giving the definition of the Markov chain which follows the pure birth process. A Markov process xt where t belongs to 0 to infinite is called pure birth process if it has to satisfy the following postulates, where we have seen the postulates in Poisson process. The similar postulates are explained here. So now come to from the Kolmogorov differential equations, I'll have P naught dash t is equal to minus lambda naught P naught t, P n dash t is equal to minus lambda n P n t plus lambda n minus 1 P n minus 1 t. The solution for the above equations where I have given in last class, last video lecture, that Kolmogorov, the solution for the above equations can be obtained by the special cases. Here the special case of pure birth process, which is also called as Joule-Furey process. So here in the above equation, if lambda n is equal to n times lambda, so from 1 I can have 0 times lambda into p naught 1. Similarly here minus n times lambda into this. Suppose we assume the p0 dash t is equal to 0, then I'll have the equation, and in second equation, suppose n is equal to 1, I am getting p1 dash t is equal to this, multiplying on both sides with e to the power of lambda t and integrating over an s, I am getting this factor. Further here, since integral and differentiations are interchangeable or inversible functions, therefore directly I am substituting the limits for this function, that I am getting P10 is equal to this. Suppose the process started with only one member at time t, then it is 0, P10 is equal to 1. So from this P10 is equal to 1, so I am getting this. So P1s is equal to this. P1s is equal to e to the power of minus lambda s into 1 minus e to the power of minus lambda s to the power anything power 0 is 1. I am writing this equation as this. By substituting 2, n is equal to 2 from equation 2, I will have this. So integrating over 0 s interval on both sides, we will get it this equation. So here I am integrating, so I am writing this factor as d by dt of this dt. By integrating on this, I am getting this value. So P20 is equal to 0. Therefore from this equation I will have this P2s is equal to e to the power of minus 2 lambda s into e to the power of lambda s minus 1. So P2s is equal to so on. So similarly P3s I can get it. So in general Pnt is equal to e to the power of minus lambda t 1 minus e to the power of minus lambda t whole to the power of n minus 1. The distribution of xt over an interval Pnt xt is equal to this, which is nothing but a geometric distribution where p is equal to e to the power of minus lambda and q is equal to 1 minus e to the power of minus lambda. So in geometric distribution we know that mean is equal to 1 by p, that I am getting this, which is e to the power of lambda t. And similarly in variance is equal to this q by p square, I am getting variance of xt is equal to e to the power of lambda t into e to the power of lambda t minus 1.